Now, what happens with the fourth electron? Fortunately, it is found in the same spherical space as the third electron. These two electrons are found in other larger spherical space around the nucleus. So, this orbital is represented as 2s2. Scientists observed the next three pairs of electrons covers different three-dimensional space around the nucleus, which looks like dumbbell and is represented with letter p. The entire space where the three pairs of electrons are found is called p orbital. As the three spaces oriented in x, y, z directions, these are called px, py, pz orbital. As p orbital comprise px, py, pz, it is also called as p subshell. The three pairs of electrons contain equal amount of energy as they cover similar shapes. Each pair moves only in their respective space. For example, electrons found in px orbital can't jump to py, pz orbitals, and vice versa. As there is less energy difference between second s orbital and p orbital, these two orbitals are represented with single concentric circle in planetary model. This single concentric circle is represented with letter L and number 2, where 2 represents the second energy level or orbit. The three pairs of electrons found in the p orbital is represented as 2p6, since it is closer to the second s orbital, which is represented as 2s2. Here, 2 indicates the energy level. The next 18 electrons cover a huge space, but the first 8 electrons take the similar shape of 2s2, 2p6, and are represented as 3s2, 3p6. The remaining 10 electrons, that is 5 pairs, cover different three-dimensional spaces around the nucleus, as shown here, and is represented with letter D. The entire space where the 5 pairs of electrons are found is called d orbital. The 5 spaces are oriented in different directions. We represent them with dxy, dyz, dzx, dx square minus y square, and dz square. As d orbital comprises dxy, dyz, dzx, dx square minus y square, and dz square, it is also called as d subshell. As these 18 electrons cover huge space beyond 2s2, 2p6, they are represented as 3s2, 3p6, 3d10. So these 18 electrons are found in the following order: 2 electrons in s subshell, comprising 1 orbital, 6 electrons in p subshell, comprising 3 orbitals, and 10 electrons in d subshell, comprising 5 orbitals. Hence, these 18 electrons are spaced in 9 orbitals, with less energy difference between them. So, collectively, the 9 orbitals are represented with a single concentric circle in the planetary model. This circle is represented with letter M and number 3, where 3 represents third energy level or orbit. The next 32 electrons cover a huge space than the earlier electrons. First 18 electrons, out of 32, have the similar shape of 3s2, 3p6, 3d10. The remaining 14 electrons, probably found in 7 orbitals, covering different three-dimensional space. This entire space is called as f orbital. These 32 electrons are represented in a single orbit, called n, or fourth orbit, in planetary model. This way, as the number of electrons increases, some electrons follow the previous patterns, and some electrons cover different three-dimensional space. We represent them on a single orbit, and so on. To get a clear picture, we begin with a planetary model. The concentric circles are called orbits, represented with k, l, m, and so on. Or, with increasing order of energy levels, 1, 2, 3, 4, so on. The k orbit, or first energy level, represents s orbital, with 2 electrons. The L orbit, or second energy level, represents s orbital, and p subshell, where p subshell represents px, py, pz orbitals. Here, 4 orbitals contain 8 electrons, a pair for each orbital. The m orbit, or third energy level, represents s orbital, p subshell, and d subshell, where p subshell represents px, py, pz orbitals, and d subshell represents dxy, dyz, dzx, dx square minus y square, dz square orbitals. Here, 9 orbitals contain 18 electrons. In this video, we discussed atomic orbitals.